Hello, Dana Paul here again. Thanks for joining me down in the shop. I'd like to start by just showing you the wood that I pulled out of the wood pile that was available to me for this tamper handle, and I can show you how I made the cuts to obtain the pieces, the three main pieces that we'll need to make the body of the tamper handle, and then we'll talk about the stitched rosewood trim ring that's going to go on the top of the handle. We were talking earlier about how to find a piece of wood that would offer radial grain on opposite sides and tangential grain on opposite sides. And typically what that means is we poke through the wood pile and look for a piece of quarter sawn stock. Now this was a piece of cherry that was a short cut off, and I had put these outriggers on it that were much longer so that I could run it through the planer and get it surfaced on both sides to make some assessment of what the grain was. For this project, I discovered that there was in the center of the piece a short or a narrow quarter sawn section that I could slice out of the piece of wood. So I just ripped out a long quarter sawn section right from the center of the sample that I had. You can see these lines run not exactly but almost parallel to the top and bottom, and that gives me a flat sawn side on opposite faces and a radial grain side on opposite faces. So this is going to let me locate four features of the pattern that I want in the center of radial and tangential faces, and it'll just line up more nicely with the grain of the body of the tamper handle. I cut a piece of that the length that I'm going to need for the tamper handle. This will be the bottom, this will be the top, and the quarter sawn quality of the piece of wood is pretty well reflected in both ends of this handle. For the pattern itself, I had a piece of rosewood that was quite a raggedy piece. It had a long section that came off that was splintered, and I was able to salvage enough to get one turning blank that'll make a tamper handle plus a little bit extra. And while I was cutting off the strips to salvage this turning blank, I wound up with a dozen or so narrow, thin pieces of stock that came off from the raggedy part of that sample. I cut a series of these about this thick and then sliced them to insert them into a billet for the top of the handle. I'm going to show you what that billet looks like. This was a turned cherry cylinder, and you can see I chucked it on the lathe. I took the router and I went down the sides and I just routed grooves from one end to the other. I routed 15 grooves. The width of those was 156 thousandths. And then I took pieces of this rosewood that I had cut from the section of rosewood that I had, and I just put 15 of those and glued them in around this cylinder. Then I took a cleanup cut. And what I have left is a billet that I can now slice rings from, and each ring that I slice off I can use for a decorative part, either in a pool cue or in a tamper handle. So I'm going to use one stitched ring cut from this billet for the top of the tamper that I'm working on. That'll give me the rosewood and the cherry in the top of the handle. We talked about the design on the bottom of the handle, that we wanted to put a finger joint pattern, one up and one down, going around the handle. So I needed some rosewood to use to make this border. I cut a small section off the bad end of this turning square that I had salvaged, and I just glued that to a piece of sacrificial softwood so that I can chuck this or clamp this in the milling machine vise, and I can use this small piece of rosewood to create the border for the finger joints at the bottom of the handle. So it'll stack up with, when it's finished, with the cherry at the bottom, the rosewood border in the middle, and then cherry on top. Then I'll slice this, the top section of the wood for the handle, and I'll insert the stitched ring in the top. I remember we discussed the concerns that exist with getting the length of each of these pieces correct, so that when the stitched ring is inserted up here and the border is inserted down here at the bottom, that we'll wind up with a handle that's 76 millimeters long to fit the barista's hand. So all of those that will be considerations that we'll take into account when we go into the other part of the shop and clamp these pieces in the milling machine vise to start the milling operations. I should mention that it's very important when the milling operations will be duplicates. In other words, I'm going to make a finger and a groove, and a finger and a groove in these pieces. It's very important that these pieces be exactly the same dimensions, perfectly square and exactly matching. So these pieces have been run through the table saw, and they all are exactly square and exactly matching, so that when I put them on the milling, when I clamp them in the milling machine vise and I rotate them 90 degrees, all of the machining that I do in the middle of the individual parts will result in the fingers and the grooves being located exactly in the middle of all three pieces. And that's the key to having the components line up so that they'll fit together without a lot of hassle at the end of the project. So the next thing we'll be doing is looking at the operations on the milling machine. And this is the awesome milling setup that I have here in the shop. It's not a 1 horsepower Bridgeport, but the price was right, and after I worked on it for about a week, I got it to where it is now extremely accurate in all three directions. The dust collection is just a jerry-rigged hose back to the vacuum cleaner over there. It's a lot quieter than hooking up the big dust collection system with a 4-inch hose, and I found that it removes all of the dust that the little cutters make in these operations on the mini mill. There's a dial indicator mounted on the back on a little plate that bears on the back of the table, and it registers movement back and forth of the table in the fore and aft direction. The left to right, not an issue in this case because all of the cuts are going to go all the way through the piece of wood. The first step on this operation is to level or flatten the top of the tongue that will be left, and then from that point I'll zero, and then I'll move down. I have a little eye gauging set up there that measures quill travel down. I'll just drop down 250 thousandths gradually for the finger joint, and I'll get the width of that tongue by just starting from center and moving off the appropriate distance front and back, so that what I have left there is 160 thousandths. So I'm just going to start the machine. I'll probably rig up another light to show a little bit better what's going on down there at the cutter, and then I'll just start the machine and make those cuts. So what I have here now is the bottom of the tamper, 160 thousandth wide tongue by a 1/4 of an inch high, and a 346 thousandths wide by a 1/4 of an inch deep groove at 90 degrees. Now you can see the grain of the wood's running from left to right as I hold this piece, and the groove is in line with the grain of the wood. When I machine the top, I'll flip the top, rotate it 90 degrees, and I'll make the groove run perpendicular to the grain of the wood. And then the intermediate piece, which is made of rosewood for the border, will pop right into this. I'll machine the top of that piece opposite, and then it'll pop right into the top of the wood. And this will all come together and before you know it. So let's move on to the top. Okay, we're going to machine the bottom of the top of the handle. I'm going to switch cutters and put the 1/2-inch cutter in so that we can machine the flat top for the tongue, and then we'll lower the front and back by 1/4 inch. Then we'll rotate it 90 degrees and cut the groove. Well, there we have the finger. (160,000ths) as advertised. So we'll just rotate this. We'll cut the groove that will allow the rosewood border to set down into the top. The groove is 346,000ths wide, so that the 345,000ths wide tongue from the rosewood can fit down into this groove. We'll cut a 312,000ths groove all the way across, 250 deep, and then we'll move it in and out 48,000ths to achieve the 346,000ths wide groove that we need in here. Well, you can see that they have just the right amount of space around these finger joints to allow the rosewood border to be installed in there. The grain will line up. Next thing we're going to do is cut the rosewood to fill in these borders, one up, one down. And the whole thing should line up nicely when we're finished. So I'd like to say thank you for watching this video, and I hope you'll stay tuned for part 3, where we'll check out this tamper handle in some detail. It actually came out very nice. Thanks very much.